Hello all, and welcome to the stream. Today we'll be doing another little freeform project. It's going to be a simple one, but it's going to be kind of cool. And I may be able to utilize this in the future depending on what we try and do here. What we're going to do today is we're going to design a program that generates charts. Yes, like a graphical chart. In particular, we can have it generate line graphs or maybe bar charts. We could try aim for both. Our goal is to just create a generic like chart object, which we can then like tweak with extensions of those objects. Today's gonna be mostly about taking full advantage of Java's object-oriented programming systems and manipulating data. So, we're going to call our project the Chart Project. Let me see if I can change the text size here. Too big. Let's start by creating a new package. I'll call it SIG, as I typically do. And we'll make a new class. We'll just call it the chart class. Chart main class, actually. This is where we're going to stick all of our main functions that we're going to make today. So our objective is to create a chart. So let's start by creating a generic chart class that we can work from. The chart class needs to contain a couple things. What's in a chart? Well, a chart usually has two axes, and then both of those axes usually have values on them. The values are certain numbers that need to be plotted along a scale, and those scales tend to have like certain ranges, like a min and a max, along with a certain like interval. So, quite a lot to take in here, but let's start with the two sets of data points. Typically when we're working with charts, we're dealing with some kind of numbering systems. So regardless of what we end up using, we need something that holds like numbers. So it seems only fair that we start with two like integers arrays, one that represents axis 1 and one that represents axis 2. And we can go even further to say that this is the x-axis data, like so, and this is the y-axis data. They can just be arrays of any size. We're going to have to insert into these arrays and do things with them. Fair enough, right? Usually we'll read the data from somewhere and we'll output a chart appropriately based on that data. Next, we need to know the min and max x. Min x, max x, min y, and max y. These represent the scales for the axes. We also want to have a size. So x size and y size determine how large the chart will actually be graphically. We're going to be using Java Swing's graphical interface as we did in a previous program in order to render this chart. And finally, we'll have like intervals, which kind of determine where extra lines are, but that's kind of optional. This is just the basics we need in order to start plotting things. We can include other stuff later. Let's just get the basics going. Let me minimize this panel. Alrighty. And this panel. So the first thing we want to do is probably create our window. So let's start by getting some J-frames and J-panels up. Now, for the J-panel, we're going to probably want to override it with the custom J-panel so we can draw to it what we want. So we're just going to call this a chart panel, which is going to extend a J-panel. So we'll create that now. think I want to say extends JPanel. And upon doing so, we have to override, I believe it's repaint. Something like that. Looks like that doesn't exist. Repaint. Oh, it might just be something paint. Components usually have repaint or of some sort. Repaint. Oh, it's just paint. We override the paint class or the paint function, which we call with the repaint. That's why I got confused. So there's our override there. So we'll start by making our window visible. We'll also set up the default close operation, which should be exit on close. That way when we hit the X button, it actually disappears. We also need to initialize our frame. And as for our panel, we also need to initialize that. And we need to add our panel to the frame. We need to set visible. We also need to set the window size. Set size. I think for this, we'll go for a 1024 by 800 display. And with that, we have our window here, and I believe a panel. We can prove we have a panel that we can actually draw to by trying to paint to it. So we'll just do a g.fill rectangle specified by the width and height. In this case, it'll just be 1200 by 1024 by 800. Starting from 0, 0. Yeah, it looks like it gets filled with a color I didn't expect, actually. I guess that's like a gray color. I did not expect that color, honestly. Yeah, okay. And that works. We can make it resizable too, but if we make it resizable, we're gonna have to reference the coordinates of that frame. So let's just change that up now. Chart main F get width and get height. That way, if we resize it, the amount to redraw also updates as well. Now then, let's get to actually working on our chart here. Our chart needs to render, so we'll provide some kind of render function here. And for our render, we will have to incorporate all these draw functions. Ideally, we have to plot all these points, and depending on what type of chart it is going to determine how it's plotted. So ideally, when we make extensions of this class, we're going to override the render method with our own version of how we want to render all the points. But we need to establish our chart first, so we'll also make a public class here that we will provide. And I'll just, let's try and create a constructor actually by using Eclipse's generate constructor using fields. And you can see here we provide all these arguments and have the IDE automatically make all this for us. We don't really have to call super, it doesn't have a super class, so, or a parent. But that works fine for our purposes. So this is the structure for a chart. The reason why I'm not actually filling any of this out is because we're actually going to extend chart with different charts. So I'm going to make a new package called sig.chart. and include other chart classes inside of there. So the first kind of chart we're gonna make is called a line chart. And this is like your line graph essentially. So like I said, we're going to extend the chart class, and by doing this, what we're saying is that we can implement any methods that this uses, but reference just one chart. We just provide the type of chart using the type of class here, and we can render any type of chart. So now we can override the render function like this. You'll notice I called super, which calls its parents constructor. So that's easy enough. Now we have to write our actual render function. So a chart naturally has like a certain rectangle of space. So we have an X size and a Y size for how large the chart actually is going to be. We have to actually render that on here. So depending on the width and the height of the window, we can kind of center the chart where we need it to be. So we'll just create some extra variables for ourselves that we can reference. So one is we can actually specify this inside of chart because it applies to both charts. If something applies to like all the objects within a parent, then you might as well just implement it in the parent class so you don't have to do it twice in a row. So we have the let's actually specify a rectangle representing the chart bounds. And the reason why I want to do this is to make it very easy for us to actually draw where the chart is located. Using a rectangle, you get an X, Y, width, and height, which is perfect for our needs. So when we initially create the constructor, we're going to set chart bounds equal to a new rectangle, starting at X position, chart main.f.width divide by 2. Then we have to subtract half of our size, so we're going to do X size divide by 2. And then for the Y position, it's very similar. We just do get height divide by 2 minus Y size divide by 2. And then for our width and height, it's just X size and Y size, like so. And that creates our rectangle there and our bounds. So when we need to reference that, we'll have that available to us. Now, as for rendering, we can first start by just rendering a, let's include graphics in here because we're gonna pass in graphics when we try and render something. So we'll do g.fillRectangle. Yeah. Let's also set the color. Like I said, we don't really have a color for the chart yet. We can provide one here if we wanted to. And we can define all those later, like back color, front color, all those good things. Background color, let's have it be that light gray for now. So that when we reference it here, we'll be referencing back color. And then fill rectangle. It's not visible. Yeah, none of these are actually visible right now. What we're going to do is we're going to make them all what's called protected variables. So protected variables make them visible inside of other children. They're just not visible to the outside world. That's why they're considered protected variables. They're only available to interact with inside of their objects. So if we need to do something outside of these objects, we'll have to specify a public class, which is what we do here, or a public function, so that they are accessible from the outside. So now that we have our background color set, we can actually draw our rectangle. So we already have a rectangle. We just need to fill it out with the appropriate coordinates. X plus chart bounds dot width. Chart bounds dot y plus chart bounds dot height. So that's the very least we need to at least render a rectangle showing where the chart is going to be printed. Now we have to actually create the chart as well. So let's make a new line chart, and initialize it. We have a lot of variables to initialize, so let's have a look at our reference here. starting with our x-axis data. Now, the data we're going to use, we're just going to make it kind of random right now. Let's just say it's going to reference like certain days. So we can do 1 all the way till, I would say maybe 30 days. That sounds reasonable enough, right? Oh, I'm making more than 30, and that's fine. That's not entirely a big deal. So there's that. And then our y-axis data, let's just make it a small number of values. Well, the y-axis data needs to be equivalent to the x-axis data, actually. It might be a good idea to make some kind of structure for this, where there are tuplets. So a tuplet is 2 values in 1. Could also be referenced as a point, like we can make a set of point arrays, right? That represents data. And that might make more sense because in the long run, we're going to be referencing them on like a coordinates like system anyway, right? So it may just be a good idea to set it up that way in the first place. So our import point here. And then we'll initialize a new set of points that way. So we'll, for now, we can make just a bunch of like random numbers, I guess, to represent this. Between 0 and 10. So if they're truly random, we're just gonna get like a very like spiky line chart in the end, which I'm cool with. So we can make this as large or as small as we want. I'm also gonna set a variable called I here to increment the numbers, kind of lazily. Like so. I can replace all those 0 commas with I++. That way we're just initializing data. And the reason why I'm doing this is just to save a little bit of time here. Because the meaning of the data right now doesn't matter to us. We just want to get some data out there so we have some proof of concept. Next we have the min x and max x, min y, and max y. Now, I could specify these manually, but what if we made it automatically do that, and then we can set the scale if we choose to otherwise? I think that would be pretty cool. Auto-scale the data for us, at least to the best of its ability. So I'm actually going to remove these next 4 arguments here, because I like the idea of an auto-scaling chart. Now, if we're going to make it auto-scaling, we're going to have to write the algorithm to auto-scale it. So we will do that now. So the min y is going to be whatever the lowest number within the second points of data are, while the min x is going to be whatever the lowest data in the first set of points are. So we have this math.min and math.max function. We can use that to consistently get all the data points out and figure out what is the min and the max. So min x is going to be 0. We'll also set max x to 0, and we'll set but we'll basically initialize all these values for now. The next thing we'll do is we'll iterate through all the points of data. Now, since it doesn't matter the order we're iterating them through, we can actually do one of these. That way P represents each point in the data, and we can go from there. So the min x, if you want to like consistently figure out what the minimum and the maximum values of like certain things are, then you can constantly call math.min or math.max on data points over and over with the value itself, along with the new data point, and see which one is greater or lower, like so. We can do something similar, but with the max function for max x and max y. The min function returns which number is lower, or which value is lower, while the max function returns which value is higher. So that way we're always setting the min to the lowest value possible and the max to the highest value possible. With that in mind, we now have our chart scale. So the only thing left to do is to specify a size. In this case, let's make a 640 by 480 size chart. And now we have all the arguments initialized for our line chart. So now we can actually call render. Point int is undefined. Yeah, that's right. I have to update the constructor in here as well. So I'm actually going to delete it, and we can have the IDE regenerate the superclass for us, the super constructor. And that should fix that. Now that we have that, let's head to the chart panel because we have to do some rendering. This line chart should actually be a static variable, so we can reference it elsewhere. Alright, so after we draw our initial background rectangle, we'll then render the line chart itself. So we'll do chart main, line chart, render. And we'll pass in the graphics. I need to update this as well because I noticed this had no argument, so there were two versions of render. We don't really want that. That doesn't really make sense. So I hit the I hit run, but nothing appears. That could be for a couple of reasons. I believe we made the background color white, so it. Oh no, we made the background color light gray, so it should be drawing a light gray rectangle as well. But perhaps we have to refresh the screen, so we'll probably do that. We also don't really repaint like consistently, so we might want to make something that repaints consistently as well. So I'm still not seeing anything, so we're gonna have to go looking at why that is. Actually, it doesn't say we're overriding render anymore, so that's actually a problem. Public void render graphics G. I don't know if it's just not here or I'm missing something, but that looks like it is the correct function, unless I didn't save something, but it looks like I saved everything. So that should be working, in theory. I see the override now. I wonder why it wasn't showing up before. Could be for a couple reasons. But that doesn't appear. But if you call this, you're also calling this up here. So we can kind of prove it's rendering or not by doing rendering. And we should see something in the line there. So rendering 2 times because it's calling it the first time when it creates the panel, and the second time when we call repaint. So that makes sense to me. However, we're still not seeing a light gray rectangle, so something's not right there. Interesting. This is supposed to be width and height, so maybe we did this wrong. Okay, so we see that. The chart bounds is not in the right place though. The X and Y should have been set or moved when it was rendered. chart bounds. Oh. I think that kind of makes sense. The width and height of the frame is not set until after we created the line chart. So let's just set the size immediately, so that way the program knows that is the width and height. So you can see now it's actually centered. It doesn't update when we resize the window because we don't have it do that yet, but we can make it do that if we wanted to. Every single JPanel has an onResize function, I believe, or a listener for a resize if you wanted to use that, I guess. So I think it's called a window listener, but I could be wrong. Let's see what we get. Here we go. Although this doesn't have anything for a window being resized, so maybe that's not what we're looking for. Let's have a quick look at the Java Swing API. Which time we got? Nice. We're on a pretty good pace right now. Let's see. Component resizing. Where is that? Component adapter. Component listener. Alright, here we go. So here's component resized. So on a resize, what we can do is we can say, hey, I've been resized. So resize the chart as well. Now what's interesting is that right now I have this called line chart, but what I should really do is just call this a chart in general. And what I mean by that is this could be any type of chart. I'm just gonna call it chart for the sake of, let me refactor this name. I'm gonna refactor it to chart. The reason being is that it could be like any kind of chart. So I don't want to call it line chart and then give the false assumption that it's only gonna be a line chart. So we're gonna call this window resized. So we do that, and we're able to now get, actually I don't know if it's gonna call it here. Let's double check, because I have a feeling the frame can call a resize function, but I don't know if the panel can. Oh, I see. Rendering just gets called over and over. Maybe we should just use that then. In terms of the actual size of the window, it doesn't seem like it updates because we need to call this after. So every time we render, I guess we should redefine the chart bounds. So let's do that. On a render, define the chart bounds, and then we can just call super.render here so that it references that as well. So you can see now, as I resize the window, the chart moves towards the center of the window. So it's always going to be in the middle. It's a nice little bonus, since apparently render gets called every time the window's resized. We can just recalculate the boundaries each time. Alright, that's great and all. Let's get to the actual creation of the chart now. The chart needs to have two axes created. So we will define one axis along the very edge of the chart, and then the other axis on the other one. So we'll do something like this. Draw line. I think we can specify the thickness of the line as well. I'm not entirely certain, but we can also just use a rectangle if we were going to do that in the first place, right? So might as well just use that if we're going to draw a line with some amount of thickness to it. So the X position is actually going to be at the X position of the chart bounds, and same with the Y. We need to this is good. We're drawing the Y-axis right now. The width is only going to be a couple pixels large, let's say 3. The height is going to be the height of the actual chart, and we'll draw it in a black color. We can actually specify axis color here. And when we do that, we need to define that inside the parent class. Axis color will be equal to color black. So there's our x-axis. Now we're going to draw the y-axis in a similar fashion. For the y-axis, the height is going to be 3, while the width is going to be the width of the chart, and we have to adjust the y to be y plus chart bounds dot height, and that draws a line at the bottom there. So now we have our x and our y-axis plotted there. Now we're going to draw some text. We don't actually have labels yet, so let's get some labels there real quick. I guess that's something we can add, huh? Protected string x label and y label. And we'll define those as new arguments in here. We'll have to update our line charts constructor as well. I'll just reinitialize that. And then we'll have to reinitialize this as well. We'll make the x-axis represent day, and we'll make the y-axis represent, I don't know, cookies. Something like that. Okay. Now we have to render the text for both of these, so for now we're just gonna do draw string. We're not gonna make it like rotated or anything weird like that, but maybe we will play around with that later if we have time. In any case, this is the, I forgot what I called it. The X label, right. So the X label is going to be drawn along the bottom of the chart, but in the middle of it. So I actually have a utility function to draw centered text, which I used last time for the Tetris game, so I'm going to pull it out again. Let me grab my utils. My lovely utils. Drag that to the wrong folder. Okay. Okay. So now that I have sig utils, we're going to be using the not this. I believe I have it already, actually. Draw utils. Draw centered text. Yes. You specify graphics. You specify a font. We're actually going to define the font inside here as a protected static variable. We'll call it the chart font. We'll initialize that as a new font. I believe you just specify what kind of font you want to use, along with a size. So in this case, let's do 24. 24 is usually a good size to start with. And we also need to specify, that's right, like the type argument, which we can make 0 because we're not making it bold or anything like that. I mean, we could. I believe the constants are located here. So yeah, we can do bold, which is 1, italic, which is 2, plain, which is 0, probably. Things like that. I guess we'll do bold, because why not? It's like a title. Alright, and then the panel itself, which is going to be the chart main.p. Then we specify our coordinates where we want to draw the text. So we're going to draw this at chartbounds.x plus chartbounds.width divided by 2. The y is going to be chartbounds.y plus chartbounds.height plus, let's go at least 8 pixels farther down. We'll make the color be black. And the actual text we're rendering, which will be X label. So we can look here at our chart text. We have an error somewhere. Hold on. Import color. Still have an error in chart this time. Or not? Oh, okay. We have errors in our util functions. That's always fine. Let's see. When looking at errors, always check what the exception is, where it's called. It looks like it's at line 95 of draw utils. Draw centered text, new attributed string. Interesting. Oh, you know what? I bet you what's happening is chart font is null. So we want to actually call charts chart font, I believe. It still says no pointer for, it actually says text, interestingly enough. Did I not define text? Oh, yeah, I didn't. That's right. This might be fine, because I think it'll reference the parents, but I could be wrong about that. We might have to correct that in a second. This .x label equals x label, and y label is y label. Oh, okay. Renders just fine. So we can see the word day is here. Now we're going to draw another text over there. So we don't actually know how large this word is, so we're going to get, let me see, text utils, calculate string bounds font. So what this function does, and it's another util function of mine, it takes some kind of value. You specify the font, you specify the text, and the panel it's going to be drawn on, and it tells you what the boundary of this font will take up. So it returns a rectangle 2D that represents how large the text is, and then you could use that in your actual coordinate calculations. So we'll usually draw this at chartbounds.x, but we need to center it. So we'll subtract bounds divided by 2, and then add a little bit of padding after that, so -4 there. Bounds.x. And that should give us roughly a good place for that text to be at. Also returns a double, I believe, so we need to cast it to an integer. Here we will specify chartbounds.height divided by 2. And so when we run this, it doesn't look like it quite put the cookies where it wants to be, but that's because we didn't get the width, we just got the x, which is actually not a very useful value, honestly. So there we go, cookies is here, day is here. Now we have to actually make our points. So first we'll just draw like little dots, and then once we have those in place, we'll actually draw, we'll actually make like a filled graph or chart to put these on. So plotting all the points. We have to iterate through all the points in all the points of data, and we have to plot them on this grid. And where they're going to be plotted is based on their x and y coordinates, which are provided to us by those points of data. So order does matter for this because we have to kind of draw them in that correct order. So again, we're going to start by only drawing a little dot. So we'll do an oval here. And at the point we're going to draw it at is actually going to be data I dot, and then you specify what you want. So it's going to be the x and the y. Now we haven't factored in our scales yet, so we will get to that. For now, the scales are actually exactly what they would be here. So we have to multiply by these sizes at some point based on our width and height. But we'll get to that. We're not going to worry about that quite yet. We're just going to make little dots, just one by one. So when we first draw this, they're going to all be in like a little corner, all smushed up. In fact, I don't even think we can see them. But I believe this is the width and height. Yeah. So we should have saw something, but I guess we didn't see anything. Or, let me see. Oh, they're all up there. So you can see in like the corner up here, they're all kind of plotted just in that little corner. So first off, we have to get them to the right spot. So we will do that by adding chartbounds.x and chartbounds.y. That at least puts it within the rectangle. Now we have to actually scale that accordingly. And in order to scale that, we're going to have to apply these, where are they? The min x, max x, min y, and max y values. So wherever this value currently is, we need to scale it in comparison to that value. To find out our scale, we need to do x scale is equal to, we can actually store this somewhere. Protected int x scale, y scale. What this is going to represent is how many pixels is each pixel mapped to data. So x scale will be equal to max x minus min x, so the difference between these two, and then multiplied by the x size. So for example, if we have 1,000 pixels to work with, and we have to show 10 different data values, like 0 through 10, then each one will be 100 pixels apart from each other, and thus 100 pixels per x position. And we'll do something very similar for the y here to get our scales. Then we can simply apply our scales by multiplying these numbers by x scale and y scale. And they disappeared. Of course they disappeared. Let's output what the x scale and y scales are real quick. See what kind of values we're getting. $83.20 by $43.20. That sounds a bit excessive, don't you think? Yeah, a little bit. In reality, we have to do x size divided by the difference. So I did the wrong mathematical formula there. Nice. So you can see there's little dots. It's kind of hard to tell because the dots are very tiny, so let's scale them up a bit. Alright. So we can see there are now different dots, and they're all on a plot. So we had, I believe, I actually don't know how many. I just pasted a whole bunch. So we have like 13 points of data here. Something like that. Plot from 0 to 13, so there should be like 14 dots. 2, 4, 6, 8, 10, 12, 14. Yeah, and they're all just plotted on this chart right now. You can see the drawing point actually starts from their corners and then draws down. So we can kind of center the dots a little bit if we wanted to. If we like subtract, we can make it a variable actually, like the dot size. Dot size. Which will make a 4 by default. Or 8, excuse me. So we can subtract the dot size, divide by 2. And we can provide dot size here and here. And that will provide a centered dot of size 8. Like so. So now that we have these plotted, it would be nice to have an actual like filled in line connecting all these together instead of just this. So we have a nice little function called a fill polygon, and we have to provide a polygon or a list of integer x points and y points along with the number of points. We can provide it in either form. If we specify a polygon, I think you provide just a constant list of points. But let's have a quick look at the polygon docs. Oops. polygon. So it's a list of XY coordinate pairs, creates an empty polygon, and then I assume you can add to it? Yeah, you just add points to the polygon by appending. That's cool. So we'll use that then. We'll have to create our polygon, and then we'll have to render it each time. It might make more sense to create the polygon once, so we don't have to keep creating it each time. Remember, doing calculations inside of the render function is never a really good idea, because you are creating a more intentional delay than you need to for the Java Swing event listener. However, in our case, we're not creating like a game, so it's not going to be in real time. But still good practice if we try and handle it somewhere else. So we're going to call this the chart polygon. Chart poly. And it'll just be available if we need it. In our case, we do need it. Now, when it comes to something like a bar chart, we're not going to use the chart poly. So that's more there as just for a line chart. So we're going to put it in here actually because it's exclusive to a line chart. So when we create the line chart, we're going to then specify the chart polygon. So we'll do chart poly equals new polygon, and then we'll add to it. And we'll do that by iterating through all the points in data and adding data i.x, data i.y. We do that over and over, and we'll have our polygon. Then we can actually use the fill polygon function instead of the fill oval. So we just provide that, and you might notice that it literally doesn't have coordinates to offset the polygon. So all of our offset data needs to go in here now. Luckily, we kind of already calculated all that, so we just need to apply it to this. With that out of the way, let's try running it. So you can see here, it's not quite what we're looking for because it's just drawing a line between all these points, so it creates this kind of inverted like shape. What we were really going for was start the polygon here at this point, draw up to here, and then draw all these, then draw back down, and then across. So we need to add a few extra points to our polygon to get what we're looking for. So we're first going to add a point at the x bounds and at the bottom of the y bounds. Then, at the end of our chart, we'll also add another bound located at wherever the last point was. So we'll kind of just from there, and at position here, we'll add another point. And then I guess for our final point, we'll end up back at the beginning. So you can see now we do indeed have this kind of chart here that renders like this. And if we were to run it again, we would get a different one because every time we run it, it's just random numbers, like so. So that's nice and all, but we might also want to have like a scale or something. And of course having the ability to change the colors. So like having the plot color would be nice. So plot color. Let's make it something nice and vibrant, like yellow. I think that would be good. Also, we don't have to draw the polygon like a million times. Just draw it once. Alright, now it's nice and vibrant. Maybe a little too bright, one might say. Let's add a little outline to it as well. So I think if we do draw a polygon, you can get a nice little outline there. It's a very small little outline, so we might need a couple of outline thickness to that. So what I'm gonna do is I'm gonna be chaining multiple loops together, and the reason why I'm doing this is to get slight offsets in terms of let's see, translate. So I'm gonna get slight offsets in terms of where this polygon is to get a like shadow effect, if you will, in a sense. So you translate it by I and J, and you'll end up getting like a thicker line, in that sense. And we actually need to make new versions of the polygon when we do this, so I'm surprised there's no clone. That's a little surprising, actually. But I guess the chart poly and all the other polygons will be different, I guess? I don't know. So this doesn't quite work the way I expect it to, because we're not going to be able to keep drawing the same polygon over and over. We could just re-render it and draw another set elsewhere, but it kind of ruins the point of doing all this. I'm tempted to just render a filled version of the polygon along all the sides that is just a different color, in a sense. I feel like that would be kind of cool too, because then we can just translate it in 4 different directions with the same polygon, which wouldn't be a bad idea, honestly. So here's what we could do. X is -1, X is less than 1, X plus plus. And in theory, this loop should make it so we end up alternating through all points. What do you think? Here, let's just do it manually first. What I want to do is translate the polygon, 1 to the right and 1 to the one down. Then I want to draw a version of the polygon there. So you can see it's like offset by 1 now. Then I want to do it again. Or, excuse me, I want to translate the polygon again and do it one more time. So you see we end up with a line like that. Then we can add another line, but going on the other side as well. So really, we can draw... I believe this one wants to be at 2, 1. So we can translate another 2 pixels over, but then we would have to translate it back 2 pixels afterward. I don't know. We'll just go -2 here after we do that. Or -1, excuse me. So we have to go 1, and then another 2, and then back 1. Something like that. And then we end up with this like little outline, if you will, of this chart. Just a little bit. Nothing crazy or anything like that. Also, the color is too bright. I'm gonna make it a little darker, like a more peachy kind of color. So we'll go for more of a like 160, 140. That's more brown colored, so let's go a little more saturation there. Alright. It's a little better. It's not quite peachy. Alright, that's a little better. So yeah, something like this. So the basics are there. We could add a scale if we wanted to. The scale can add plot lines like on the bottom, and then we can add like little labels if we wanted to or something to indicate what they actually mean. So if we wanted to do that, for each of our points, we would try to implement one of those. Now this is also assuming that all the data is evenly spaced out. If the data wasn't evenly spaced out, then we'd have all these like uneven spaced lines. So maybe it's better to draw a certain set of lines at a certain scale. So again, X scale and Y scale can come into play here. We already know that each value represents a certain number of pixels on the scale. So we could just draw all of those as well. That's another idea. So we could say from I is I is min x, I is less than max x. So we could just go through our entire scale like this. We would just have to make sure that where we drew them was relative to those values. So the position we're going to draw the line at is actually going to be not fill, we're going to draw a line. And this line will be at position, so if min x was 0, it would be at chartbounds.x. And then every value thereafter kind of follows the same idea, right? For each value, you multiply it by x scale, and then you have your line, essentially. Your line position. So I'm actually going to put this outside because we can reference this in the next call of draw line. So this is going to be the x position, which is represented by chartbounds.x plus, we're going to take I minus min x, because I will keep increasing over time, and multiply that by the x scale. And that will give us our x position. So we can type in x position here. The y position, pretty easy. We just put it at the bottom of our chart. We can like subtract 4 from it because we're going to add to it as well. X position will remain the same. And then chartbounds.y plus chartbounds.height. We can add like 4 here or something. Whoa. Why did the color change? Is the real question. Oh, somehow this turned into a 0. How? Why? Okay. All the lines get overwritten because we draw the polygon on top of it, probably. So we can see down here we now have tick markers. And I actually wanted the tick markers to go further down. I don't know why it didn't quite do that. I guess the plot itself goes a lot further out than I thought. Either way, we have little tick marks there. Actually, I don't even see the 2 original lines we made for the axes, so let's put those back. Probably at the bottom. There we go. Anyways, for each of these plot lines, we can go ahead and actually mark down what they represent, like value-wise. So, depending on the scale, that's going to determine what value they represent. But let's draw the other axis first. So we'll kind of do a similar idea here, but we'll be changing all the values, of course, and we're going to be starting at the bottom of the chart and working our way towards the top. And then we're going to subtract from here, multiplied by y scale. And then we're going to draw this line, starting at position -8, -8, or not -8, but chart bounds x -8. And then along the y-axis, we're going to draw the y position. It looks like I did not quite give these any good width. There we go. So now we got some horizontal and vertical tick markers, which allow us to at least vaguely see how they're divided up. If we want to, we could also add in some numbers. How much time we got? Alright. It looks like we've reached about that 1 hour. Today's exercise was mostly to get a feel for object-oriented programming style. I do want to share how to do a bar chart though, because you see we did a line chart, right? And we rendered all this stuff. And that's all great. But how do we use, how do we extend an object for other types? Let me show you. If we make a bar chart and we extend chart again, we can kind of use a line chart as like a template to make the bar chart class. And actually, it's not too much different from the line chart. For example, if we just simply import this render function here that we made from line chart, we already have a lot of the stuff we need. We don't need the chart poly because, well, the polygon itself does not get rendered, so that already leaves us with all this. Now, how do we actually implement the bar chart? Well, instead of using a line chart, we just use a bar chart. The cool thing is, because they're both from the same parent object, what ends up happening is all the functions that were called before still remain the same. If I were to run this now we're calling a bar chart instead, and we just have to actually specify the bar chart's drawing algorithm. So specifying the bar chart's drawing algorithm is not too difficult. We can make it pretty quick here by iterating through all of our data points. And for each data point, we're going to be drawing an offset, and we're going to be drawing a rectangle. So we're going to do something like this. Fill rectangle. Let's do a 3D one. And we will start from position wherever we're at, multiplied by the x scale. Actually, data I dot x multiplied by x scale. Again, that determines our x position in the grid, and then we have to add our chart bounds to that. And then our y position, which is going to be very similar, but we're going to be at the bottom of the chart. And then we will actually decrease it by the amount of y, and then our scale. So our x scale will actually be a certain set width. It's going to be, let's do x scale divided by 2. That way there's like a bit of equal spacing between all the bars. And finally, the y scale is going to be this value. Because what this value represents is all the missing parts that were raised up. And that's how far down we have to go in the rectangle. We're going to say, yes, it is a raised rectangle. That's all we need to display all those. So you see we get a nice little bar chart here. It doesn't actually go all the way across, which is interesting. But I do see like little lines here, so I think those are all zeros, and it might have just been coincidence. Yeah, there we go. So you can see this is a bar chart instead of a line chart. And it's representing the same data using the same class, just now we're using bars instead. So that's pretty nifty. This does go a little bit outside, so if we want to make this better, we would like center it, squeeze things in a little, things like that. But yeah, that's a basic implementation of making a chart type of class and sharing it using parent classes, so we can create all types of charts using a very similar structure. So it's pretty nice that we made a parent class and then referenced the parent class with children, And then these children, while they all behave using similar rules, they also have slight versions of their own. The final thing I want to do real quick, since I know we're going a little over time today, but that's okay because learning is good. I want to make it so after I render the chart, I want to also output it to a file. So here's what we're gonna do. We already have painted the window at this point. We're just gonna repaint it one more time. So we'll do a p dot, or not here. We need to do that in chart main. Actually, we can do it here. Every time we render the chart, we're going to save a version of the chart to a file. To do that, we can first convert our graphics context to a graphics 2D context. And Java Swing does explicitly say that you can convert any graphics context to graphics 2D safely. The reason why we have to convert to graphics 2 is because what we want to do is, I believe, save this image. Let me see. It's not called save, but I know from here, graphics 2D is like, gives you access to a lot more functions, which is why we use it. But I know we're gonna have to do an image.io.save, because image.io contains the ability to create images. Oh, here it is. Create. That's not what I'm looking for either, though. Let's see. Oh, right, here it is. So we can write to a file. So we have to provide an image, and that's where G2 comes into place, because we can actually do, I believe, get flip bounds? No, not quite. Let's see. I might have to look this one up real quick because I think I have missed something here. Let's have a look. Save graphics to, oh, there we go. We've done this before. So yeah, we have to make a new buffered image, okay. And then we just have to write to the buffered image after painting, so you have to apply the, wait a second. New buffered image. Create graphics. That's what we're looking for. I could have sworn okay. Creates a new graphics object that has a copy of this graphics object. Format name is PNG. Chart.png. That's a good name for it. Rendered image. What do we have to do then? I guess we have to save it to a... Oh, I see. You paint the panel's contents to an image. That's what we're trying to do here. Buffered image. New buffered image. I think you just specify a width and a height from the looks of it. So in our case, it's just going to be the Windows width and height is what we're looking for. This is like akin to like saving a screenshot basically of the window, but we're having the program do it. And then I think there's something else. Oh, maybe that is it. Oh wait, we have to specify the color type, that's right. Let me see what they call that. It's just an int. Let me see what they put here. They're constants. Buffered image. I think we just normally use int with alpha, red, green, blue. And then from there, we're supposed to paint all, or let me think. Image what am I missing here? Create graphics from the image. Oh, and then paint onto that. Okay. So get the graphics 2D from the image. Then basically render everything we would render there to here. Interesting. I guess we have to grab the panel then. So is this the panel? No. Chart main dot panel. Paint all. Paints this component and all of its subcomponents, and we're just gonna paint directly to. So I guess we don't need to repaint then. I don't think we did, but anyway, paint all onto this graphics, and then I guess you just supply what looks to be just the buffered image itself. And then I guess we need to add in... What else do we have to do? That's it. Hello? Oh, we need a file. How about that? So file object. And then finally we just have to do a throws if we need to. There we go. So every time it's drawn, we'll also have to throw any of these that fail on render, because they're parents of that class. And also, that would mean we have to throw, or we have to handle it here, I guess, because, well, there's no place else for it to throw. What? What happened? What'd I do? Let's see. Stack overflow error. That means it like looped on itself. That's not good. So we call paint, which calls render. Render calls this, which calls paint. I see the problem. We don't want to do it there then, do we? We want to actually call it inside of a place like chart main. So just paint and create the image here is what we're trying to do. Okay. So that should have saved an image somewhere. Hopefully we can find it. I think I called this projects, but I don't see it. So let's go in here. Where did I save this workspace? I saved it in here, apparently. Did I not call it oh, I called it practice. Okay. Here we go. It's a chart.bng. Boom. There's our chart. And if we switch to using a line chart instead, we can get a line chart as well. So there's a line chart, and chart.png outputs a line chart. So there you have it. Just some basic functionality that could prove useful for a lot of things. We rendered to a graphical interface again using Java Swing. We generated a chart. We did a little bit of mathematics to calculate where to draw stuff on the screen. We did a little bit of object management by creating a parent class and then creating children of that class and using properties from both here, and talked a little bit about how to relate variables back and forth between them. I made something semi-useful. I might be able to use something very similar if I polish it up a little in the future for a project. So I think it could come in handy for a lot of different things, but it's a nice little exercise. For those of you that tuned in today, hope you enjoyed and learned something. I will be posting this project on my GitHub as always and linking it in the video description, so you can get a copy of the source code there if you would like. Thanks for watching, everyone. Have a good one.